Good morning. Welcome to the second day of the main program of the 2019 Embedded Vision Summit. Did you enjoy the conference yesterday? Excellent. I attend more conferences than I care to think about, and I'm easily irritated, especially when conferences are not well organized and I wind up wasting a lot of my time. We've really worked hard this week to arrange things from the signage to the schedule, et cetera, to make excellent, efficient use of your time, and I hope we've succeeded. There are about 50 people involved in planning and executing this event, most working behind the scenes, very dedicated to making this event run very smoothly, making very efficient use of your time, delivering the right content in the right form. I want to thank them all very much for their hard work to make this all possible. Thank you. And by the same token, we know we can do better, and we need your feedback to figure out how to do better. You've got evaluation forms in with your event guide. Please take a few minutes throughout the day to jot down your thoughts and give us your feedback. That's essential. We read every comment. We tabulate every score on every presentation, and it's really essential for us to figure out how to do better next time around. So please give us your feedback. I thought yesterday was awesome. I learned a tremendous amount. Still digesting much of what I learned and planning to watch the videos of the presentations I couldn't see live, but a few things really stood out for me I want to highlight here. First, I really enjoyed Ramesh Raskar's keynote presentation yesterday morning, and what finally clicked for me after hearing him explain it is if we can control the timing of how we capture light in image sensors and other kinds of sensors, for that matter, with the very, very fine time resolution, not only can we make these amazing videos, but more importantly, we can do amazing things. We can create cameras that can do things like see through fog and see around corners, which sounds like science fiction, but it feels now like it's very possible just over the horizon. We had many presentations and also product introductions and other product presentations yesterday showing really promising progress on enabling deep neural networks that are not only very accurate, but also very efficient in terms of their use of computation and memory, which of course is key to enabling them to be deployed widely. And I think the continued progress in that direction is super encouraging. Making vision systems easier to design is another theme that I saw running through many of the presentations yesterday, product presentations and otherwise. Things like automated techniques for optimizing design of deep neural networks simultaneously for accuracy and for efficiency. Things like sophisticated reference designs and modules so that system designers don't have to build everything from scratch, but can reuse, whether it's software or hardware or system architecture, can reuse proven design components to save time and reduce risk. I think this is huge to enable more and more people who don't have and don't really want necessarily to have all the expertise from the bottom to the top of the stack to successfully incorporate vision into their systems and applications. Rudy Berger from Woodside Capital always has some great statistics in his presentations, and I was amazed to see that over $1.5 billion has been invested in the past 3 years in AI chip startups. For reference, if you look at the previous 3-year period, this is more than was invested in all chip company startups in the previous 3-year period. So this is an amazing kind of renaissance of silicon design driven by AI, primarily by edge AI or embedded AI applications with their tremendous volume potential. I know many of you caught the very engaging and thought-provoking presentation from Steve Teig of Xperi, the chicken and the data center, which to me really opened my mind to, well, on the one hand, it's really quite remarkable what these deep neural networks that we have today can do. But on the other hand, there's a tremendous amount of important things that they can't do. And Steve, I think, shined a light to illuminate a path for how these algorithms can be improved over time, including being aware of the concept of time and principles of physics, for example, and structure of objects in order to be more capable in the future. Our speakers have put a tremendous amount of work into their presentations, gone through multiple rounds of reviews with all of them. They've all been very receptive to the feedback and have really tuned their talks to be the best they can be and the most relevant they can be for this audience. I think they've all done a fantastic job, and I want to thank them all for their hard work. I want to particularly commend Bi-Chan Wu from UC Berkeley. Bi-Chan graduated with his PhD yesterday morning in Berkeley in the rain. Congratulations, Bi-Chan. Ran home, changed out of his wet clothes, and drove down to give his presentation here. That's the kind of dedication I like to see from our speakers. By the way, slides from all the summit talks will be available to you in the next couple of weeks. We'll bundle them all up in a zip file and send you an email, so you'll be able to get access to all the talks. And recordings, either slides plus audio or slides plus audio plus video, will also be made available. That takes longer because each of them is individually edited and then sent to the speaker for approval before publication, but those will be done on a rolling basis starting in the next few weeks, and over the course of the next few months, those will be made publicly available. And the best place to find out about those videos as they become available is the Embedded Vision Insights newsletter. If you're not already getting that newsletter, it's easy to sign up on the Alliance website. After my talk yesterday, a few people asked me, what exactly is this Embedded Vision Alliance? So let me take a minute to answer that here. The Embedded Vision Alliance is a partnership of companies that care about practical computer vision technology and applications. These include companies building building block kinds of technologies like sensors and software tools and processor modules. And they include companies that are creating systems that incorporate computer vision across all kinds of industries and applications. And the Alliance's mission is twofold. On the one hand, we want to inspire and empower all kinds of product creators to make better products by incorporating computer vision, visual AI, visual perception, whatever you want to call it, into those products to make them safer, easier to use, more capable, more efficient, more autonomous, and so on. And secondly, we work with companies throughout the ecosystem, especially our member companies, to help them get what they need to be successful in this space. Often that's insights into technology or market trends, developer preferences. Often it's connections to key suppliers or early customers or investors or other kinds of partners. So this is what the Embedded Vision Alliance is about. If you work for a company that's in one of these two categories, making the building block technologies or building systems with computer vision, I'd invite you to come by the Embedded Vision Alliance booth in the Technology Showcase exhibits and talk with my colleagues there to find out about Embedded Vision Alliance corporate membership and the benefits and programs that come with that. Another question I get asked frequently is, why focus on vision versus other types of perception or other domains of AI, speech recognition, what have you? And of course, there are many domains of AI and many domains where deep neural networks are showing tremendous progress and capability. In the physical world, if we just limit ourselves to perception, there are, of course, many, many different kinds of sensors. This is a market forecast and historical data from Semico Research on sensor unit volumes shipped for many different kinds of sensors. I believe that visual data is the most important among these many types of data produced by many types of sensors from the physical world. One reason I believe this is that from visual data, with the right kinds of algorithms, we can extract so much valuable information, much as humans do. Get so much valuable information visually. Most of the information, in fact, that comes into our brains comes in visually. I think paper I read estimated that at 70 or 75% of information that comes into the human mind comes in visually. Another argument for sort of the primacy of visual data comes from, I think, a very clever insight from Chris Rowan that I'm going to reproduce here. if you look at this chart, the red segments in these stacked bars are image sensors. And I apologize for the very small type, contrary to my instructions to all of my speakers. The very small type on the key on the right there, but the highlighted red bars near the top of these stacks, that's image sensors. And the key information here is that you can see that image sensors ship in tremendous volume, soon to approach 10 billion units a year. But there are plenty of other image sensor types that also ship in very large volumes. Chris had the insight to modify this chart based on the amount of data that sensors produce. For each sensor type, he multiplied the number of sensors shipped by a typical data rate, bits per second, that type of sensor produces. And what you get is this. What happened to all of the other sensor types? Well, they're basically a rounding error compared to the amount of data produced by image sensors. The amount of data produced by all other types of sensors combined is basically a rounding error because image sensors ship in as high, in many cases much higher volume than other classes of sensors, and image sensors produce orders of magnitude more data than virtually every other kind of sensor. And so when you combine those two facts, you get this reality. And of course, this is not a rigorous analysis. This is more of a thought experiment. But I think to a first order, it is correct to say that most of the data produced by deployed sensors is and is going to be image data. Now, not all data is valuable, but going back to my comment a minute ago, we know that there's a tremendous diversity of useful, actionable information we can obtain from these pixels. And so this, to me, helps underscore why visual data is perhaps the most valuable, the most interesting kind of data if we're going to try and have devices perceive the world around them. Another interesting tidbit I recently came across is that looking at all patents filed recently regarding AI in some way, almost half of them, 49%, are actually computer vision patents. So I think that's another interesting indicator, given that we know companies are going to focus their money and time filing patents where they think there's likely to be some commercial value in the future. We have another great day planned for you today, starting with this morning's keynote, which I'll introduce in just a few minutes. The structure of the program today is very similar to yesterday with a couple of important differences. Like yesterday, we're going to have 6 parallel tracks of presentations. Today, they will all start at 10:45 a.m. after a short break that follows the keynote. The technical insights tracks, 1 and 2, are for intermediate and advanced level practical technical presentations that cover algorithms, optimization techniques, application case studies, design trade-offs, and the like. The fundamentals track provides introductory technical tutorials on a wide variety of important topics. Business Insights track provides market analysis, investment trends, application case studies, new business models, and similar topics. And finally, the Enabling Technologies tracks are where companies are presenting the latest commercially available technology building blocks, the software tools, the camera modules, the new processors, and so on, that you can use in your systems to take your capabilities to the next level, your system's capabilities to the next level. Yesterday, the Enabling Technologies track started after lunch. Today, it'll start at 10:45, along with the rest of the tracks that I've mentioned. We'll also have an afternoon break today, like yesterday. In addition to the lunch break at noon, there'll be an hour-long afternoon break from 3:15 to 4:15, which is a great opportunity to visit the technology showcase exhibits. There'll be snacks and drinks available in the technology showcase during the afternoon break, and that's also where lunch will be served starting at noon. Same floor plan as yesterday. The Technical Insights 1 talks will be in this room. Technical Insights 2, just out the door to the right, the room behind us. Go back towards the registration area and up the escalator. That's where you'll find the theater, where the Business Insights track is taking place. Opposite the theater, down the short hallway, you'll find the Fundamentals track in rooms 203, 204. It's actually one room, 2 combined. And then in the exhibit hall itself, in the technology showcase in the back left and the back right segments there, you'll find the 2 presentation areas for the 2 Enabling Technologies tracks, ET1 and ET2. If you're signed up for one of the all-day workshops or seminars tomorrow, they will be 2 of them. The Chronos and Synopsis events will be upstairs in the 200 rooms that I just described opposite the theater. The 2 Intel workshops will be at the far end of the convention center on the 2nd floor in what's called the Great America Meeting Rooms. Just keep going down past registration, past the exhibit hall. Eventually you'll see a staircase. Go up there and you'll find the Intel workshops. There'll be plenty of signs guiding the way. If you haven't signed up for one of these Thursday workshops or seminars and you're interested, there's still some space in the Synopsis workshop, which I think is a great opportunity to get some in-depth insights into Synopsis's very interesting processors for embedded vision applications, as well as getting some interesting perspective on some of the broader challenges of designing embedded vision systems for markets like automotive and consumer. A highlight of the program today is our Vision Tank startup competition. This has actually been underway for months, and it finishes today in the Vision Tank session at 4 p.m. in the Business Insights track. We had 49 startups enter the Vision Tank competition after a rigorous evaluation by our panel of independent judges. 5 were selected for the final round. Those are the companies listed here. They are all super interesting companies that are the cream of the crop that survived this culling of almost 50 down to 5. And now they're going to compete in the final round, and 2 are going to walk away with top prizes at 5 p.m. today. One of those top prizes is going to be an Audience Choice Award. So if you come to the Vision Tank session at 4 p.m. today, you'll have a chance to weigh in by text message voting on your vote for the top company from this very strong field of startups. I was delighted to see a lot of engagement in the Vision Technology Showcase exhibits yesterday. Seemed to be a lot of very intense conversations going on with pointing to circuit boards and screens showing vision algorithms running and so on. I was also really impressed with the capabilities that were being demoed. I think a big step up from what I saw last year in terms of the level of the technology, the sophistication. Lots of interesting demos, really leading edge, enabling technologies being demoed. If you haven't visited the Technology Showcase, it'll be open today from 10:45 a.m. to 6 p.m. I definitely encourage you to make some time to stop by, see these interesting demos, and in many cases you'll have an opportunity to talk to the people who are creating the technologies, to the design engineers, the product managers, the applications engineers, and so on. Thanks again to the lead sponsors of this year's Embedded Vision Summit. And I want to particularly note that several of these companies introduced brand new products in the Enabling Technologies track presentations yesterday that I thought were very compelling, and others are demonstrating new products that they've announced in the last few months. Things are moving very, very fast in this field. Stop by their booths in the showcase to find out more. The Embedded Vision Alliance conducts an annual survey of product developers, system and software and application developers who are using computer vision to understand their technology choices and challenges. And we focus primarily on people who are working in industry, who are building end products, systems, as opposed to components. This slide shows data from the last 3 iterations of the survey showing the adoption of deep learning among commercial system product developers. It's pretty remarkable. If we had the data going back another 2 or 3 years, the number would be close to 0. So this is a technology that's gone from roughly 0 adoption to roughly 60% adoption in something like 5 years. When does that happen? This is really a special moment in technology history. This data, to me, quantifies and solidifies something that I think many of us have sensed and been aware of, but it's hard to quantify. It's hard to know if this is just your individual bubble you live in or an industry-wide phenomenon, and I think this data makes it really clear that it is an industry-wide phenomenon and that the rate of change is remarkable. Deep learning has transformed computer vision in the past few years, not just in the research realm, but clearly in the commercial realm as well. Many things in this field are changing fast, and this is part of what we try and do in the Embedded Vision Alliance is help people stay aware, abreast of developments, and up to speed on important new technologies, and that's something that I hope we're helping you with today. If you'd like to see additional excerpts from our developer survey, you can download a white paper with additional excerpts from the survey at the URL here, or stop by the Embedded Vision Alliance booth to get a pointer to the URL, or possibly a hard copy if we still have them left. There are many software frameworks used for creating, training, and evaluating deep neural networks. But one of the really striking results from our developer survey is how TensorFlow has come from nowhere over the last few years to totally dominate this space. This is the same demographic that I mentioned on the previous slide. This is commercial system software and application developers building computer vision-based products. What you can see here is that 84% of them are using TensorFlow, not necessarily exclusively, because you see these bars add up to more than 100%. People may use multiple frameworks, but TensorFlow, more than twice the number of respondents indicate they're using TensorFlow than the next most popular of these many open source deep learning frameworks. TensorFlow, of course, is an open source deep learning framework originated by Google, and our keynote speaker today, Pete Worden, has really been instrumental in the creation and adoption of TensorFlow.